This is chapter 6, section 4, which is basically dealing with logarithmic functions. First thing to understand is that exponential functions are inverses of logarithmic functions and vice versa. Remember the definition of an inverse. If an exponential function is x comma y for the ordered pair, logarithmic functions become y comma x. We just flip-flop x and y. So what happens here is we have a problem 12 to the 5th power equals m. That's an exponential form. If we want to change exponential form into logarithmic form, we put log of whatever base it is. In this case, the base is 12. The value, and then it's always equal to the exponent. So the 12 comes down here where the base is, the value comes here, the exponent comes here. Same thing holds true here. Here we have base e to the b power equals 9. You can write it as log e 9 equals b. Now remember from previously, log e can also be represented by natural log, ln. So whenever we write an ln, we are writing log e. And the last one here, we have a to the 4th equals 24. So this becomes log a, 24, the value, equals 4, the exponent. Another thing we have to do here is we have to be able to solve logarithmic equations. And what you're going to see is in example example 4 of your textbook, okay, it says log 2 16. Well, what you want to do is anytime you get a problem like that, you want to write it as log 2 16 equals y. Then you want to take that and put that in exponential form. So we're going to do base 2 to the y power equals 16. Then we're going to solve it like we solve any exponential problem. 16 can become 2 to the 4th power, so y equals 4. We come over here, here's a logarithmic equation. And so in terms of this, basically what happens here is we're going to put it into exponential form. So we have base 3 to the 2nd power equals 4x minus 7. 3 squared is 9. Now we can add 7 over, get 16, divide by 4, we get x equals 4. Remember that in terms of this, in terms of graphing these, and just taking a look at an example problem from the book, where we have ordered pairs here, just remember that in terms of this, here is the graph of y equals 2 to the x power. Here is y equals log 2x. So what happens here is we have the ordered pair of 1, 2. That's the regular function, or the exponential function. The logarithmic function has 2, 1. We flip-flop x and y. If you look here, we have 0, 1. Here we have 1, 0. Switch x and y. Here we have negative 1 half. Here we have 1 half, negative 1. Switch x and y. So remember that exponential functions and inverse functions are inverses of each other.